Variables and expressions. Okay, let's define a variable. That is a placeholder that represents some number. And we usually use letters for that. So, for example, we can just say A is a variable because we're going to put A in and let it represent any number we want it to. Algebraic expression. Okay. This is an expression or a set of numbers, variables, and at least one operation. So a group that contains numbers, variables, and at least one operation. Oops. Okay. And let's write an example of an algebraic expression up here. So example, 3c squared minus 6. It's an algebraic expression. Okay? It has number. It has an operation. It also has a variable. So it meets all of the requirements. It has numbers, variables, and at least one operation. Okay? Also, in this one, it has terms. Okay? Let's use another example to describe those. Okay? So second example, maybe just 4c plus 8. Oops, I don't want my finger to be that. I want my pen to be that color. Okay, so with 4c plus 8, 4c is a term. Okay. And 8 is also a term. Okay. Just parts of the algebraic expression that are divided up by addition or subtraction. Okay. So within this first term, 4c, okay, so if our term is 4c, the number 4 that's multiplied in front of the c is called the coefficient. Let me check my spelling here for this one. Coefficient. Okay? So coefficient is the number multiplied in front of a variable. Or sometimes we just say the number directly in front of the variable. Okay. The other term, the second term in this one, this 8, is the second term. Okay. So that one has a special name as well. The 8 is called the constant. Okay. Constant term. Because it's a term that contains no variable. Okay? It'll always be 8. No matter what we plug in for a variable, it'll always be 8. Okay? That leads us to evaluating an expression. Okay? Okay, to evaluate an expression, we're going to use a substitution property. Okay? So that substitution property says that if two things are equal, you can plug one in for the other in an expression. So in this case, A is 3, as it says right here in the instructions. A is 3. So wherever there's an A in an expression, like right here, I can put a 3 in for that A. Okay. We also have C, and up here it says that C is 4. So we should be able to plug both of those numbers in. Okay. An important thing to remember is that when you plug in to this expression, I've got the 6. I need to put a 4 in there, but if I just put the 4 down right next to the 6, it's going to look like the number 64. But that's not what our problem says. It says we're going to take 6 times C, not 6 and then a 4, 64. It's not 6C as in like a number in the 60s, okay, like 64. It is 6 times C. So we need to make sure that when we put this in, that we get 6 times whatever number it is. Okay, so a good rule of thumb is when you're plugging stuff in, and there's multiplication around it, just put it in parentheses. Okay, so I'm going to plug that 4 in for the C, so I'm replacing the C with a 4, and I'm going to put it in parentheses. Okay, and I can also do this with the A, put it in parentheses. A is supposed to be 3. Now in that case, the parentheses don't really mean anything, but it might not be a bad habit to start forming, okay? Because then you don't screw other things up. Okay? You always make sure that you're multiplying when you're supposed to be multiplying, and you're subtracting when you're supposed to be subtracting. Okay? And if you happen to be plugging in a negative number, these parentheses really help you out. Okay? And now we just have to solve it, because that's what evaluate means. We want to know what the value of the expression is. Evaluate. Find the value. Okay? So we're plugging in numbers using the substitution property and then finding its value. So 6 times 4. Well, 6 times 2 is 12, so 6 times 4 must be 24. So we'll replace the 6 times 4 with a 24, and we still have a minus 3 in there. So 24 minus 3 is 21. Okay? So that's example A. Okay, let's go ahead and evaluate the second one. I need to look back up here. We've got a C. Ooh, we're using C and A again. Okay, so C was 4, it says up there, and A is 3. Okay, so we'll replace the C with a 4, and I'm going to put it in parentheses. And we'll replace the A with a 3. And let me check that again, because my memory's not that great. It does say A is 3. Okay, and now let's go to order of operations here. This top one, we did that correctly, because order of operations says multiply first and then subtract. Okay, because please excuse my comes before the S, Sally, right? And please excuse my dear Aunt Sally. Okay? So down here, well, we've got a fraction bar, and that thing needs to be last. Okay, fraction bars are last, because we remember in order of operations that we pretend that we have big grouping symbols on the top and the bottom, in the numerator and in the denominator. Okay. So let's evaluate all of the numerator, because I believe that the denominator is finished. It's a 3, we can't do anything with that. Okay? So the first thing we need to do in the numerator is evaluate, well, we've got a set of parentheses because we put them in there, that around the 4, okay? But there's nothing inside of them to do. So the next thing, PE, excuse, or exponents, okay? We need to solve this exponents. 4 squared, that is 16, right? So 4 times 4 is 16, so we have a 3, and then parentheses 16 over 3. Okay, now there's 2 ways to go from here. One way is to take the 3 times the 16 and then divide by 3 in the end. But the faster way is, since I have a 3 in the numerator and a 3 in the denominator, I will cancel those, because 3 divided by 3 is 1, right? So 3 divided by 3 leaves me with a 1. 1 times 16 is 16.